We're now going to look at the probability calculator, which is a very useful feature that we have in GeoGebra. So it comes up here, like the standard normal curve would have a mean of 0, standard deviation of 1, and at the moment it's set up for a two-tail situation, and it actually calculates for you exactly what it is, what the probability of a result within that area is, and you can see between 1 and -1 you've got 0.68, which is what you'd expect, and if it was between 2 and -2 it should be equal to 0.95, which it is. We can also have a one-tail approach to the probability from either end, and of course you can change this. So I always like working with 60 and 15 as good numbers, and we can then just manually slide these around. Okay, so really cool thing is from here you can certainly take a copy of it and put it in a Word document, very easy, or we can put it into the graphics view. So, and that's actually quite a cool thing to do, because once it's here, for starters, it has the same sort of functionality. This A here is actually the probability. But what we can do instead is use a text box and say that, well, I'll call it just the area, it won't be too technical. The area is equal to the value of A, which is 0.8, so it works it out automatically for us. So, and we can select that text and make it bold and make it a little bit larger as well. Okay, so this bit of text here, we can just get rid of it. Alright, now we can certainly change the sliders here, but we can't actually change the mean and standard deviation, or can we? Well, looking back at the previous screen, the value for the mean was 60 and 15. If I look over here in the algebra section, you'll see the numbers 60 and 15 appear at different times. So we know the 60 is a reference to the mean, right there, and the 15 is a reference to the standard deviation. So we're going to set up some sliders again. So I'm going to have a slider here, and the first one, we want it to be the mean, so we can actually use the proper symbols for this. So the mean, I'm going to make it an integer, and let's say the lowest mean I'd ever want to have would be down to about 40 and up to about 75, and it goes up by 1, so that's fine. So that's it's reverted back for some reason. There it is. Okay, I've got the mean, the random mean, and now I want to get the standard deviation. So standard deviation, again I'll make it integer. It's going to be, say, small to be about 5, so yeah, up to about 30, and that's 1, and I want to change that to be the standard deviation is this one. There we go. Alright, so we have this, and nothing's happening at the moment, but all we have to do is inside here, where it says 60, replace that with the mean, and where you have the 15, we know that that's actually referring to the standard deviation, and that therefore is also referring to the standard deviation. Alright, if I hit enter, now, as well as experimenting with moving these values around, I can also experiment with moving the parameters of the actual normal distribution as well. So plenty of opportunities to move things around. The other thing is you could bring in something additional and say that let M say be equal to the x value of A. So it's the x value of A is going to be equal to M. So that's taking that out of there. You'll see why I'm doing this in a second. And N is equal to the x value of B, because this is essentially your A point and your B point. And then we could make a statement here in a text box which goes something like, and we're going to use latex to make this look really nice, so probability that the lower one is going to be M. So the probability of M is less than X is less than my N value is going to be equal to whatever that area is, and the area is just equal to the A. So we have this statement here. No, that's not quite what I wanted. This A is actually the variable A instead. I was a bit too quick. Alright, hit A, there it is there. Okay, so I can make this a little bit larger. Alright, so as I move this across, the area is changing, and then that's changing the lower bound. You can see that value changing and the upper one changing. So you've got a fully dynamic model for working with the normal distribution.